Welcome to March 9th LeetCode Challenge. Remove duplicates from sorted lists. Given the head of a sorted linked list, delete all nodes that have duplicate numbers, leaving only distinct numbers from the original list. Return the linked list sorted as well. So we're given this linked list here, and surprise is already sorted, but we want to remove any duplicates. So we have 3 that are duplicates and 4 that are duplicates. So we remove all the duplicates. So that leaves 1, 2, and 5 remaining. Example 2, we have 3, number 1 has 3 triples, or so more than 2. So therefore remove all the 1s, and therefore we're left with a linked list that's sorted that has 2 and 3. So the constraints of the number of nodes in the list of the range between 0 to 300, the values of the node range between -100 to 100, is guaranteed that the list to be sorted is sorted in ascending order. The list guaranteed to be sorted in ascending order. Alright, so let's see. I'm just going to develop a solution and then we'll kind of improve upon it. So what we want to have basically a resulting set, and that's going to hold the linked list node object that we did, and then we want to have the next value inside it equal to head. Alright. Let's see if this notation is done appropriately. We'll just call it head inside. Hopefully that works. Alright, next thing you want to do next is, I'm actually going to assign it to next. Do that. Alright, next thing you want to do is develop a previous pointer to our results, and then develop a current pointer to our head. So while current is true, if the current dot next and the current value is equal to the current value, next value I should say, then we are going to check the next node if it's valid, and its value as well. So what we're going to do is delete the value. So how do we know when we want to delete a value? So our candidate, let's call it candidate to be deleted value, and then it's going to be the current node value, and then we want to delete the node if it has the same value as current. Right, so we want to delete the value if it has current. So to do that, we need to check it, right? So we're going to check if the current exists, and the current value is equal to the candidate value. Then we will want to remove it from our linked list. And to remove it from a linked list, there's a little bit of a pointer exchange that has to happen to remove it. And without boring you too much with the detail, I'll just kind of just write it out. So next node, assign a variable to capture the next node, and we'll call it current node.next. And then we will want the previous next node to be assigned to the next current node. So to do that, we do prev.next is assigned to current.next. So notice how the next node and the current node is updated like that. They're both the same, and then we want to update the current.next node to be none. So therefore it's basically or closing that loop, and then the current node has to be assigned back to the next node. Alright, and that's pretty much it for there. And we exit this while loop, exit the if loop, and then if else. So if the current next node does not exist, or the current value does not next value does not equal each other, then we would use to update the previous value to the current value. Current. And then we want to update the current value to be the current.next value. And then we just keep on looping through each node. At the end of this, we exit the while loop, and if everything goes well, we should be able to return what am I doing? Return the results dot next. So that, let's run this a little bit. It might not work. Alright, it has some form of making it work. However, let's take a look at this a bit more. So if we run it, we're attempting to say that this just visits the entire linked list kind of twice almost in a way. So one for finding the duplicates, right? And another time for removing it as well. So there's a way to probably look at see the number as well, find the duplicates and remove it at the same time. So we want to find whether so this is a valid solution, it works. However, we could actually, we don't know if it's sorted or not, right? Because it's guaranteed that it's guaranteed that's sorted. I'm gonna just submit it and see if it works. Because we can improve it a little bit more. Alright, excellent. Yeah. I mean, if it works, I'll just leave it there. I mean, there's another little addition you can make here, but just to kind of make it more robust. But if it works, I'll leave it there, and that's it. Time complexity is big O of n. Actually, we loop while to loop. You know what? I'm gonna actually make it a little more neater. So we see how we have to loop it through twice here. So as I said before, we loop through it once to find duplicates, and we loop through it again to remove it. This is a valid solution. However, we can leverage the sort property. Just check the current node is the same as the previous node. If it is, then we can mark the node to remove and move on to the next node. So this is an edge case to handle just in case if the head is the linked list is removed. But we'll take a look at that because if head is a double, this example 2, and remove that, then we lose our pointer to it, to our list. So let's think of another solution where we could, so we'll use the same idea here. So let's just erase all this. So we want, let's say, previous is equal to, let's see, how are we going to do this? So while cur, if this is equal to that, then we have a candidate. So what we're going to do is remove all this section here and say that if previous exists, then what we do is previous.next is assigned to the current.next, else, so hopefully this will be a little bit quicker, the head is equal to current.next. And everything else is the same, else. Then we just want to exit this loop here and update current.next to be none. And then current will be equal to the next node. Let's run this code, I hope it works. Alright. Alright, that wasn't even very quicker. I mean, it's pretty much the same. Alright, then, that's it. Have a great day, guys. Oh, time complexity wise is big O of n squared? No, n. Yeah, and because we do have a while loop here for current, and then this current does the same thing again. So it's debatable, but I'll just call it big O of n, and space complexity is big O of constant space, which is basically changing the original list. So we're removing stuff from the original list, so therefore we don't really have extra memory for it. Alright, have a good day, guys.